Knowing and understanding the graphs of the reciprocal trigonometric functions is quite important. So what I'm going to do is base all that I'm going to do in this video on previous facts that you should know about functions, but I'm going to reiterate them in this video. I'm going to focus this video on cosecant, and cosecant is basically the reciprocal of sine. So this is 1 over sine theta. And that's basically what we're going to use to determine what the graph of cosecant is going to be. So one thing to note is let's say our theta is sine. And so what we're going for is 1 over the function itself. So we're going for 1 over sine theta. So just So what we're going to do is compare some of the properties to know how it's going to look like in the reciprocal function. And these properties apply to any reciprocal functions. So this is 1, -1. I'm just going to reduce the graph just to show how it's going to look like. And then okay, so this is my original sine function. And these are some of the facts that you could deduce or you could try on your own. So one thing to note is that the zeros of sine x, or the zeros of your function, will be the vertical asymptote of your reciprocal, because if at, let's say at pi, f of pi is equal to 0, then you are going 1 over 0, so it's going to be undefined. So exactly where sine theta is 0, that's going to be your vertical asymptote. So I can do a dotted line. I'm going to do it in purple. So we have a dotted line at 0. Okay, this doesn't show. I have a dotted line at 0. We have a dotted line at 2 pi, don't forget the 2 pi. And we have a dotted line at pi. So all of these is where our reciprocal is undefined. So our function is actually going to be chopped up. Now if you have a negative domain here, you'll continue the same thing. Wherever sine theta is 0, you're going to write a vertical asymptote. So the zeros become the vertical asymptote, and then if you have a y equals to b as your y-intercept, then this is going to be your y-intercept. So where is the y-intercept here? It's 0. So 1 over 0 is undefined. So this is going to be your y-intercept. This is just invalid in our case. Okay, this y-intercept becomes the vertical asymptote. But I do want to put it there just in case you're doing other reciprocal functions. If I have a minimum at here, it's going to end up being the maximum in the reciprocal, and vice versa. If you have a maximum here, it's going to end up being the minimum. Now this is not going to be clear at the moment, but it will be. So we have, this is going to be your, and we're talking about local minimum and maximum, so only within that region. So 1 is the maximum in the sine theta, so it's going to be the minimum in our reciprocal, and -1 is our minimum in sine theta, so it's going to be our maximum in the reciprocal. Again, I'm talking local, so within the region itself, not going further. So we're going to use this fact in a bit. Then we have that if f of x is bigger than 0, so it's positive, then 1 over f of x is positive as well, and vice versa. So if it's negative, then it's going to be negative. And that makes sense because you're doing 1 divided by a positive or a negative number, so the sign will stay the same, which means this is the positive. The vertical asymptote is nicely cut into the positive and negative side. So this means that we will be using the positive y value, and we will be using the negative y value, so we're not touching here. And then the last fact, just to help us graph it, because you're thinking, well, we haven't graphed anything. As f of x tends to 0 here, our 1 over f of x will tend to either a positive or a negative infinity. Now, why is that true? Because as your f is getting small and it's getting very close to 0, you'll end up dividing by a very small number. And as you're dividing by a very small number, your fraction will end up being very, very big, and you can test that out. Now, if you studied limits, this will make sense. If you haven't studied limits, just use the calculator to test out. If you go 1 divided by 0.5 and then go 1 divided by 0.25, this is going to increase. It's going to keep on increasing as your denominator is decreasing. So as f of, sorry, I keep on writing x, theta. As f of theta is increasing, reaching to 0, your reciprocal is going to get close to plus or minus theta. Now it depends on the sign. So here's where we go. We have, this will remain the same, and you can test it out. So if I have sine of pi, 1 over sine of pi is going to be, this is equal to 1, so 1 over sine of pi is 1 over 1, so this is a coordinate. And this is where the maximum and minimum stays. The coordinates stay there. So, and then I have sine of 3 pi over 2 equals to negative 1, which means 1 over sine 3 pi over 2 is equal to 1 over negative 1, which is negative 1. So we already have the coordinates 3 pi over 2, negative 1, and pi over 2, 1. Now, what's happening here is now I'm going to use this fact we did as it gets to 0. So as f is getting close to 0, you're noticing that the y value is decreasing. It means my reciprocal is going to reach infinity. And it's going to be positive because we said if f of theta is positive, then the reciprocal is positive. It means that my function is actually going up to it's going to go to a big y. Yes, the x is getting smaller, the theta is getting smaller, but the y value is getting bigger. And similarly here, it's going to get, as it's reaching a 0, it's going to keep on increasing. And this is where the asymptotes come to play. Your curves are getting very close to the asymptote but not touching it. And we're also sticking to this positive means positive. We are still in the positive. And then similarly here, my function is getting very close to 0 as the theta is decreasing, so this will go infinity, and we're going negative because we have a negative, we're in the negative y, and then similarly here. Okay, so let me just undo that. Okay, so the black is the reciprocal. This is the 1 over sine theta, or cosecant theta. And you'll notice this with most of the reciprocal functions, you'll always get those vertical asymptotes because you'll end up dividing by zeros. And then see, we maintained the minimum maximum. So within here, this is our minimum, local minimum value, and this is our maximum value. I know it goes to infinity, but we're talking about local minimum and local maximum. So hopefully this video is clear. I would encourage you to do this exercise with the reciprocals of tan and cos as well, just to practice how it's going to be. Also notice that you don't get any values between -1 and 1. So this would be an observation that you could look into.